If you've not already watched the video on how to calculate the area of squares and rectangles, then we suggest that you watch that video before watching this one. This video is based on an actual question from a state math exam. It's possible that you will also have a question like this one on your 5th grade state math exam. A cube and the net of a cube are shown. The surface area of the cube is 54 square feet. What is the length of one edge of the cube? Before we answer this question, let's review the following. What a cube is. What are edges as seen on a cube or pyramid? How to see edges on a drawing of a three-dimensional shape. What a net is. How to see edges on a net. And the meaning of the tiny squares on the face of a net. We'll start by describing what a cube is. A cube is a three-dimensional shape with 6 faces that are made of squares. We use the word face to refer to the flat part. There are many common examples of cubes, such as ice cubes, sugar cubes, and some wooden blocks. For prisms and pyramids, an edge is the name of the line formed between 2 faces. These are just some of the edges on a cube. There are 12 in total, but we can only see 9 of them in this view. Here's an animation of a yellow cube that's made of glass. That glass is tinted yellow. This is what the cube would look like that the question is about if we could spin it around. Solid lines on a drawing are edges that we can see directly. If this cube was on a desk in front of you, then you could touch all of the solid edges while keeping your arm and finger straight. Dashed lines on a drawing are edges that we see indirectly. That means we can only see them if the walls are made of glass, and we're looking for some walls, as with this animation. If this cube was on a desk in front of you, then you could not touch all the dashed edges while keeping your arm and finger straight. If we could unfold this cube and lay it flat, we would get a figure like this. We call this a net. There are many nets that go with each three-dimensional shape. We made a playlist that shows many nets for each type of three-dimensional shape. A net shows each face of the three-dimensional object. For example, here's a front face on a cube before it's been unfolded. And here is that same front face after the cube has been unfolded into a net. When a single edge is unfolded on a three-dimensional object like this cube, sometimes the faces will move apart from each other, as in the case of the front and right face of this cube. If the faces move apart from each other, then both faces get an edge. In this example, a single edge on the cube between the front face and right face is now 2 separate edges, one on the front face along this side, and one on the right face along this side. Other times, the 2 faces stay connected to each other, as in the case of the bottom face and the back face. If we return to the net shown in the question, we can now see there are lots of edges. We've shown them inside these blue rectangles. Please note that some of these edges are solid lines. Those are the ones on the sides of faces that are separate from other faces. In contrast, some of the edges are shown as dashed lines. Those dashed lines represent edges that are between 2 faces that are still connected to each other. Something that can confuse students is that the dashed lines on the drawing of a three-dimensional shape and the dashed lines on a net have different meanings, as we've demonstrated in this video. Sometimes you'll see other solid lines on the faces, which we're highlighting in red. These are called grid lines. They're used to help us measure the length of an edge, or to calculate the area of a face. Together, these grid lines form many tiny squares, which we're showing as purple squares. The value of one tiny square depends on what the question states. In 5th grade, state exam questions often show each tiny square as being equal to 1 unit. In this question, the unit is feet, rather than being inches or centimeters. So each of these purple squares is likely 1 square foot. A square that is equal to 1 square foot of area has a width of 1 foot and a height of 1 foot. Now, we're ready to answer this question. They're asking what is the length of one edge of the cube. Since a cube is made of 6 square faces of the same size, we can pick any of these 6 faces to answer that question. Let's pick the face on the left. Since this face is a square, all of its sides are equal length. Each side of a face is called an edge. We could choose any edge to answer this question. We'll choose this vertical one. Now we can count up the tiny squares to find the length of this edge. We get an answer of 3. Since each tiny square is likely 1 foot high, that means the length of this edge is likely 3 feet. So All the edges of this cube are likely 3 feet long. Choice B is likely the correct answer. But you might be wondering why we use the word likely rather than being confident about option B. The reason is because maybe each square is not 1 foot wide and 1 foot high. If the length of each side on these small squares was a little bigger or smaller than 1 foot, then the length of the edge would be different than 3 feet. If we wanted to know for sure that each tiny square is equal to 1 square foot, then we need to count up the number of tiny squares. When we do that, we have 54. Then we compare that number with the surface area that they told us, which is also 54. Since both of these are the same number, that tells us that each square is equal to 1 square foot. We know that 1 square foot is 1 foot wide and 1 foot high. So now we can be confident that the length of each edge on this cube is 3 feet. After 5th grade, we'll learn another way to answer this question, even if there are no grid lines on the faces. But for now, the above approach may be easiest. Thanks for your attention.